Good evening, guys. I'm Chris, and welcome back to this Wednesday's episode of Rift Amps. Before we start, do buckle in. It is a long one. I had quite a lot I wanted to film to squeeze into this video. I could have split it into two parts, but some of you have been asking for a longer content video, so we're going to give it a go, see how that turns out. Enjoy. Back on with the Cat Wildcat 40R. Now, for those who are new to the channel, haven't been following this amp, this is the one which the customer's owned for a very, very long time. And he said it's always eaten a set of output valves, often very quickly. He's had other techs look at it at the past, and they've often drawn no conclusion from what they found. So, but he's asked me to have a look at it to see what we can do. Now, I got this thing on the bench. The EL34s that were supplied with the amp weren't installed. They were in the bottom of the cabinet. And when I asked him about that, he said he thinks one of them has actually started to short. And I've stuck it on the tester now, and that is indeed correct. So that's why I couldn't get on with it last time, because I had to find a sacrificial set of EL34s that I could install in the amp and measure voltages. But if the amp does destroy them, it doesn't matter. Anyway, I've been through the old valve box, and I found a pair that are close enough matched for testing purposes. It will be fine. An old set of JJ. So they're in, and the amp is on and up and running. It's made a couple of little pops and crackles and things like that, but nothing too much. Now that it's fully warmed up, it's drawing 134, almost 135 watts out of the wall. Now, today's wall voltage is surprisingly high at 245, almost 246 volts coming out of the wall today. It's a very high voltage, and it's pulling 628 milliamps of current at idle. Times those two together, and you get 134.8 watts. So that's what it's doing at the moment. So I've looked online. I couldn't find a schematic for this amplifier. I found a tube layout, I found an owner's manual, but I couldn't find a schematic dedicated for this amp, which means if I'm fully going to understand what's going on in the output stage and why it's cooking its valves, I've had to draw out a schematic, or at least a partial schematic for the output stage at the moment, because that's what I'm interested in. First thing I have noticed when it's on the bench is when it's in half power mode, it's pretty quiet actually, but you put it in full power mode and you do get a 100 hertz hum that you can hear. I think it's 100 hertz. I need to double check and measure it, but there is a hum in place. And now I'll show you why it's doing that. Well, you'll see why it's doing that when I get to the schematic. So I drew it out by hand, first of all. There she is. And now I've done it a digital version, a proper version, so we can look at this together and understand what's going on. Now, it's a pretty typical cathode biased output stage, to be honest. There's nothing too complicated with this, nothing over the top, nothing awkward or strange or weird. But this is what we've got. So we've got our two EL34s, V8 and V9. And the anodes, the plates, connected straight to the output transformer as normal, as usual. This one at the top is the white wire. And this one at the bottom is the yellow. Okay. Straight to the output transformer, nothing else going on. Output transformer itself gets its high voltage from B plus node 1. Okay. The screens, so grid 2, have 1K 10 watt screen resistors. It's not a shared resistor, it's one each per valve, and that gets its high voltage supply from B plus node 2. Again, pretty standard at this point. Grid 1 are control grids. We've got 10K grid stoppers coming in. Not your typical value for an EL34. Normally you find them around 5K6, something around there, but 10K, that's fine. not an issue. The cathode arrangement, the cathode biased amplifier. So each cathode has its own dedicated cathode resistor, a 270 ohm 10 watt resistor. And so there's one each. And there is cathode bypass capacitors, 220 microfarads on each side. Now, this is the half power switch. It's not converting this from pento to triode mode. The half power switch, as it's labelled on the amplifier, is a double pole single throw switch, so both contacts close at the same time, and it just removes those caps from circuit in half power mode, back up to full power. It brings those caps back in. Now, this hum we're hearing when we are in full power mode is these caps in circuit, so maybe those caps are faulty, but that's not the issue that it's coming for. Anyway, so to fully understand what's going on with the circuit, of course we need to take some measurements. Now, I say this 100 times, 1,000 times, 1,000,000 times, it doesn't matter, people still don't understand it. When you're taking your grid 1, grid 2 and anode measurements, they're always referenced to the cathode, not ground. Okay? So you always measure at the cathode. Now, in a fixed bias amplifier, the cathode might be tied directly to ground, and therefore it's one and the same thing. But your measurements, and it's crucial in a cathode biased output stage, your measurements are always referenced to the cathode. So your black lead on the cathode itself, pin 8 in this case, or pin 1 because the suppressor grid is tied to pin 8. And then your measurements are taken with reference to that, because that's what the valve cares about, that's what the valve sees. Okay? And this is what we've got. So our voltage, anode to cathode, they're pretty identical both sides. Here's the original measurements, so you can see they're close enough that near as damn it we could just work on one side. Anode to cathode voltage, 389 volts. Okay, so it's sub 400 volts. Fine. EL34s can handle up to 500 volts. Okay, so they're not anywhere near the limit. Screen voltage, about 40 volts lower, 349 volts. Not bad at all. Okay, happy with that. The voltage from the cathode to ground, so across the cathode resistor, 23 volts. And the value of that resistor, of course, resistance cathode, is 270 ohms. So using Ohm's law, V equals IR, we want to know our cathode current, the total amount of current flowing through that cathode resistor. Okay, well, current is voltage divided by resistance. So we can go 23 divided by 270 ohms gives us 85.1 milliamps, but we always work in amps, so it's 0.085 amps. Okay. To work out the total dissipation, and bear in mind the cathode current includes the screen current. The cathode current is a combination of the screen and the anode current. So both of those together, we can say that figure. Sorry, we need Joule's law, don't we? Power is voltage times current. So we can say our current figure times 389. So these are running at 33.13 watts. And as a percentage of maximum, EL34s are 25 watt output valves. We're currently running, so you take that figure, divide by 25, gives us 132%. Okay, are you with me? So yes, these output valves are running far too hot. Ideally, we want that number closer to 100. As close to 100 as we can get it. All right. Because we've also got the screen dissipation in there, Up to 105, 106, probably okay. If this is the way we're going to measure it, we could calculate the exact screen dissipation, subtract that from the figures just to get the anode dissipation. But if we do it this way, we always remain safe. So yes, I would say with these output valves biased to 132%, we are screaming hot. That's far too much. So how do we change the bias on this amplifier? Pretty easy, really. Here's the cathode resistors. We simply increase their value. That's all we got to do. So the E12 series of resistors, in this case, we've got 270, which we know is far too hot. The next one will be 330, 390, 470, 560, 680. Okay, so and on and on and on. So the next, if we are here, we're probably, this is going to be too far, I would have thought. So we're going to end up at one of these values. So let's see what we can dig out. See if we can find. See, I've got these in stock. If not, I've got to order them. But see what I've got in stock. We can install whatever I've got, retake the measurements, see where we end up, and go from there. The other sum we quickly need to calculate is the power dissipation or the heat dissipation of those cathode resistors. Power is voltage times current. So the voltage across the resistor, 23. And we times that by the current flowing through the resistor. So times 0.085 is 2 watts of current, 2 watts of power being dissipated by that resistor. We normally double rate as a minimum. So we need 3.9 watt resistor, so 4 watts will be fine. I've got 5 watt ones here. Okay, so I can put 330s in at 5 watt and go from there. The ones that are in the amp, the 10 watters, obviously they're quadruple rated, or 5 times rated, in fact, aren't they? So, yeah. But anyway, we're going to swap these in, see if that brings our bias down, runs these slightly cooler, see if our current dissipates, sorry, our wattage consumption from the wall decreases. I'll tell you what we should do while we're here. Is let's just measure its output while I've got it. Right, Q&A time. As you can tell, the sun is out. Beautiful day today for all those fans of my weather updates. But apparently a storm is coming. So, we're going to suffer the tail end of a storm in the middle of the week. Hopefully it's all gone by the weekend, because I'm racing at Silverstone on Saturday. And at the moment, it says it's going to be a sunny day, but who knows. Anyway, Q&A's. Got quite a few questions this week. Let's start with Mark Tierney. And he says, I've heard that the UK versions of the deluxe reverb reissue don't have an optical tremolo because of some kind of restrictions on the chemical used in the Roach. Is this true? And do you have to stick to bias harmonic style tremolo in your amplifiers? Yes, our amps don't have the optical tremolo. That's UK and European models. And you're right, it's because there are restrictions on and it's an element actually, not a chemical, used in those tremolo bugs, the Roaches, which is cadmium. Cadmium is one of the substances listed on the Registry of Hazardous Substances, often referred to as ROSH, along with things like mercury and lead. Lists all the things that you can't use in your electrical goods. And it says you can use it as long as it's below a certain amount listed in parts per million, right? Effectively it outlaws all these things. It's why we have to use lead-free solder, for example. And that's the law. And there are big fines if you try and get around it. Now, those optical bugs, contain a cadmium compound. So it's not just cadmium. It's I don't know what the word is, but it's part of a compound, which means you can't use them. Now, what we have to have, and this actually goes back to question I had last week about CE compliance, things like that, is we have to keep a technical file for every amplifier we build, and in the bill of materials in that technical file you have to state what the component is, whether it's a machine screw or a potentiometer or a resistor or anything, and you have to say what it is, what the spec is, where it came from, how many of them you use in that amplifier, is it ROS compliant? Of course it has to be, and you have to have a copy of the data sheet for that product. Now, the data sheet might be supplied by the manufacturer, or it might be supplied by the supplier, the place that I buy them from. And that data sheet has to say whether that product is ROS compliant or not. And all of the Octobugs out there, one, they don't come with a data sheet, so you couldn't use it even if it was compliant, because you have to have the data sheet. But we know that they're not compliant anyway, so they wouldn't ever have a compliance certificate with them. So yeah, that's why they're not used. So I cannot manufacture an amplifier with one of those Octobugs in them. And it's not just those things. There are many components that contain banned substances. A lot of old transistors and old valves. So I have to use new valves in all of my builds. I can't put new old stock valves in because I don't have a data sheet for them, or they might not be compliant anyway. There's a lot of those old transistors that are used in boutique pedals, not allowed. Not allowed, and the fines for doing so are huge. So yeah, you've got to be really on your toes. So yeah, that's why. So all of my tremolos are bias trem, but to be honest with you, designing an LFO is not difficult. Getting it to work is not difficult. So if I was going to do a black panel deluxe reverb build, or a super reverb or a vibroverb, I'd do it with a bias trem. It sounds better anyway, so I don't know why you would. But yeah, good question, Mark. Okay, so I've got this thing running on the scope. 1 kilohertz, 150 millivolt sine wave going into the front end. Master of the amp on full, cut completely out of circuit, and I've advanced it. Now, it's strange. I can't quite get a definitive point where it starts to round off. But around 16 volts output seems to be the best compromise. Now, 16 volts gives us 32 watts. So is it down on power? I don't know, because I don't really know how they measured the output of this amplifier, because they haven't given any specs for it. Sorry, let me just zoom out. There you go. So I'm going to go with that. I mean, it's not unhealthy, we could put it that way, but I can't get, well, 40 watts will be smidge under 18 volts. That's 17.6, and that's at that point definitely overdriving. So, but anyway, let's bring it back up to 16 volts. There we go. Half power switch. Let's do that. So just removing those two caps. Here they are, these two at the end here. Remove those, and the output drops down to 6.5 volts, which puts us at 5 watts. So it's more than a half power switch. Isn't that interesting? All it's doing is just jumping these caps in and out of circuit. Anyway, now we've got a baseline anyway. Let's get these cathode resistors swapped out and take more measurements, see where we end up. Brian Filmuth says, "Hi Chris, follow-up question from last week regarding valves adding harmonics. why does the output trace on the scope still look like a perfect sine wave with a dozen or so harmonics embedded in the signal? Shouldn't we be able to see higher frequency waves on top of the original one? Not higher ones, no, or not the very top ones. Sometimes you can see a prominent second order harmonic on the sine wave, and sometimes you can even see an out of phase harmonic. And I'll put on the screen now examples of what those would look like. But the problem with an oscilloscope is that it has limitations, or its limitations are also its strengths, in that it's designed to show you the sine wave in the time domain, right? So left to right on the screen, it's showing you the sine wave over time. What a spectrum analyzer does is it takes a cross section of that sine wave and looks at it head on, so you can see all of the content within that sine wave, and that's where all that harmonic content is, and that's what it's used for. So if you imagine here, this is a sine wave, and the reason I'm using a spring is because this is actually what a sine wave is. It's not a straight up and down, it's a rotation around a point. And when we say something is out of phase, where say we're starting here, when it reaches the bottom, it curls around, gets to the bottom, and that's 180 degrees out of phase. It's rotated like in a circle. If you look at it straight on, if you're at the top, 180 degrees out of phase is at the bottom of the circle, right? So when you're looking at a sine wave, you're actually looking at the side-on profile of something that, like a spring, like that. And when we take a cross-section of it and look at it head-on, we can see all of the content inside, right? And that's what the spectrum analyzer does. Thankfully, it doesn't display it like that. It then organizes it all in a frequency domain, so we can see left to right, low frequency to high frequency, and that's what they're for. So, and that's why it's really important for an amp designer to have one, so you can see exactly what's going on inside the signal. Okay, new cathode resistors are in. That's not a permanent install, don't worry, it's just for testing. Because if they're not the right value, I'm going to take them immediately back out. First thing we notice, wall consumption has dropped down to 124 watts. Good thing, as expected. Okay, I have taken the measurements. So these are the originals, and these are with the 330 ohms in place. Our anode to cathode voltage has increased by 2 volts. Our screen voltage has increased by 6 volts. The voltage drop across the resistor has increased to 24.3 from 23. Now, why are they doing that? Well, as current decreases, voltage increases. So again, this is what we expect to happen. Okay. The value of the resistor, 330, it means we've got a total cathode current of 74 milliamps. Down from 85, so we have cooled it off slightly. We're flowing less current through the valve, so it's running cooler, which means our total dissipation anode plus the screen grid, remember, it's down from 33.13 watts down to 28.8 watts, and the percentage of max, that's 115%. Now, that's got me closer to my target than I thought it would, just by going up one step on the chart, right? We've got closer than that. And do you remember I said we could calculate the screen current, the screen dissipation, and then see how that factors in? Well, that's what I've done. So the voltage drop at idle across the screen resistor, 8.96 volts. As you overdrive the amp, obviously that increases. The resistance, of course, is a 1K resistor, so 1000 ohms. Means we've got 9 milliamps of screen current, or 0.009 amps. So we can then deduct that from our cathode current. 74 minus 9 is 65. So our anode current at the anode, is 65 milliamps. Times that by our anode to cathode voltage, we get an anode dissipation of 25.4 watts, which is 101% of maximum. Remember, the maximum is 25. So we're near as damn it there now. I'd be quite happy with that. If we go up to a 390, we're going to cool the amp off even further. But are we then going to go too far the other side? Unfortunately, I've looked through my box of high wattage resistors. I haven't got any 330s in stock, which is strange because I've had a quick look and I ordered some a couple of months ago and I don't know where they've gone. I must have used them on something, but I can't remember what. Anyway, that I have got 470s, but I haven't got 390s. So I think the best thing to do now would be to stick with the 330s because I'm much happier with these numbers than I was with these. Much happier. And perhaps that's now tipped the amp back towards a safe, reliable operating point compared to where it was. So let me soak test this amplifier now and I'll heat cycle it a few times. So I think the best thing to do, because obviously the customer definitely doesn't want to be bringing this thing back in, is let's give it, well, the time now is 20 to 3 in the afternoon. So we'll call that 2:30. Let's give it until 5:30 this evening. So we'll give it 3 hours on the bench, running, putting out voltage. There it is. Make sure we've got some tone controls up, so it's passing some nice frequencies. And let's leave it running. Let's leave it running, see what it does. See how happy it is. We'll get it screaming hot. We'll come back. We'll take those measurements again. And if the amplifier performs much better than it does before, performs more reliably, then I'll reinstall these resistors properly, do a permanent install on them. Then we can hunt. Then once that's done, and I'm happy with that, we can then hunt down the cause of the hum, which I suspect will be these two caps that need swapping out. They're probably just at the end of life. All right. Good progress. Okay, David says, nice content. Thanks for keeping us solder addicts going. You're more than welcome, David. Question. I've seen more than a few Fender repairs, restorations now, that seem to have DC leaking through the circuit board. We're talking about vintage Fender amps here. Does that present much of a problem or can it be safely ignored? Yes, it can present a big problem, and no, it cannot be ignored. The boards over time take on moisture and become conductive, and you have no control over which part of the board becomes conductive, and therefore which parts of the circuit are effective. Now, Fender realised this, and in some of the later amps they started covering those boards in wax. If you look at the later silver plate amps, they're kind of covered in a wax to stop that moisture absorption happening. But no, it can cause serious problems in the amplifier. Any tech can easily diagnose it and find it, but how you fix it depends on the severity of it. It could be simply from removing the components from that area of the board. You heat up the board as much as you can. Try and get rid of any moisture, evaporate it off if you can. A heat gun or similar. People use isopropyl alcohol just to try and get the moisture out. Sometimes you need to completely remove the entire board if the board's really bad and try that. Or ultimately, it could be a new board job. So, best thing you can do is if your amplifier isn't showing any symptoms yet and hasn't had any issues in the past, keep the amplifier in a cool, dry place. Put a silica gel packet in the back of the amp, in the inside of the cabinet when you store it, and have the thing serviced regularly. So these things can be checked. Any tech worth their salt will do a quick check for board conductivity on any of those amps now, and if they're not, you shouldn't be using that tech. So I do it as a matter of course on any of those amplifiers, especially the rarer more expensive ones, like the Gary Moore Bassman, for example. You know, if my reputation would be gone in a second if it turns out that that had a conductive board and I'd sent it out the door, right, and didn't check it. So yeah, you've got to really be on it. But yeah, you can't ignore it. Absolutely not. Because they never get better on their own. They only ever get worse. Thumbnail and title time then. Here we go. This is one really cool Marshall. This is what we believe a 1975 Marshall 50 watt 1987 model head. And it's in really nice condition. As you can see from the Tolex, the badge on the front, and the control panel. So 4-hole non-master volume, square indicator light, JMP. Really cool amp. This is the one that everyone wanted. We look on the back. So serial number is 2577E for Echo, lead model. Yep. Main selector, impedance selector, mains fuse, HT fuse. It looks like it's already had the IEC replaced, which is a good thing. Last pack tested 2023. So what's it in for? Not much, to be honest. The owner just wants me to give it a good check over, service it as required, make sure it's performing as it should be. Now, I have in my head, because I should have looked this up before I started recording, I'm not sure whether this is an EL34 model or a 6550 model. We'll have to find out when we open it up. I think the Mark IIs were 6550s, but honestly, I don't know if they were US models only. I'm not sure. So we'll find out. But yeah, just wants me to make sure it's all okay. He says he's not convinced that it is sounding exactly right, but would rather me cast my eye over it, look through the circuitry, check it out on the scope, see what's going on, see if we can get an answer for him. Okay, 4 screws removed from the rear panel. Is it just me, or does anyone else absolutely hate flathead screws? I just don't understand. They're so bad. Anyway, right, rear panel off. Let's have a look inside. What can we see? Looks like it's had the 1, 2, 3 filter cans replaced, but it does look like it's got the original mains transformer, output transformer, and choke, which is a good thing. Output valves. Marshall branded EL34s. Made by JJ. I don't remember them ever having the white sockets. Might be wrong. Might be wrong. Okay. Apart from that, can't really see much else. There's the build label. 1973. It's a 1973 model. Very cool indeed. Right, not much else to do on the top. So let's get this thing. Let's get the chassis out of the cabinet and have a look inside. Just doing the heaters on this PR18 build. So just bear with me, I'll get this solder joint done. And we'll look at the next question, which is from Michael Smith. Thanks for the question, Michael. He says, interesting comment that the Deluxe Reverb amp originally planned to use 6L6 output tubes. The plate voltage on his Deluxe Reverb at roughly 65% idle dissipation is 437 volts, which I understand is above the designed maximum for 6v6s. Yeah, Deluxe Reverbs always push 6v6s far too hard, which is how they managed to squeeze 22 watts out of them. What's involved in a conversion to run 6L6s? Not much, to be honest. Not much at all. Remove the old 6v6s, install your 6L6s, check your bias. That's it. You might need to adjust some one of the dropping resistor on the bias board to try and get the bias range where you want it, because 6L6s and 6V6s do have a different bias point or require a different bias voltage. But that's about it, really. It's not much. That's all you've got to do. So the power transformer has enough heater current to run 6L6s. In fact, if you add up the requirements for the amplifier, the power transformer has exactly the right amount of current to run the 6 preamp valves and the two 6L6s at 6.3 volts. The output transformer, the impedance on a Deluxe Reverb is 6K6, 6K7, depending if it was a later or an earlier transformer. Now, Fender historically, all the way through the tween amp eras, on the two 6L6 amps, used the 6K6/6K7 output transformer for their 6L6s. For 6V6s, they always ran 8K transformers. The later and the bigger 6L6 amps ran the 4K2. Yeah, 4K2 output transformers. So that amp, as stock, is designed and capable of running 6L6s. The theory goes that at the very last, that's the way they designed it, and at the very last minute, maybe they got a good deal on a new batch of 6v6s that could handle higher voltage than the old ones, or whatever it was, but they switched to 6v6s at the last minute. Now, interestingly, because of the voltage in a 6v6 equipped Deluxe Reverb, if you install, rather than an 8 ohm speaker, a 16 ohm speaker but running on the 8 ohm tap, you actually move the output transformer impedance up to 12.5, 13K, and that kind of matches better with the plate voltage in the amp, and the bottom end suddenly comes all together, stops being spongy and farty as Deluxe Reverbs generally have. So yeah, it's a really interesting one. But alternatively, you just plug a set 6L6s in, tweak your bias circuit, and away you go. And like I said, I've done quite a few conversions now, and those players who are out there using those amps live, they always get the comments, why did your Deluxe Reverb sound much better than everyone else's? Well, because it's running 6L6s, right? So there you go. Have I soldered that other one in? Yeah, I have. So that's a good question. He says, as a side note, I recently installed a baffle board insert using the Exister speaking mounting studs to accommodate a 10-inch speaker. I had tried 3 or 4 12-inch speakers in my Deluxe Reverb, and they all seem kind of dead in that cabinet. Does he say what year his Deluxe Reverb is? No. The 10-inch Jensen Mod 1015 is much more lively and has plenty of bass response. In fact, I have to turn the bass pot down on the control panel. If I were you, I would go back to a 12-inch speaker, try the 6L6s. The bottom end will do exactly what you want in the way that you want it. Personally, I don't like single 10-inch speakers. I always think they work best in multiples. Doing that, not that, sorry. So yeah. Great question, Michael. Yeah, but seriously, try it. Put a set of 6L6s in your Deluxe Reverb. get a nice bias point. Don't bias it to a number. Bias it to, use an oscilloscope and a signal generator. Get a nice clean output sine wave. Remove any crossover distortion, and that amp will sound incredible. So for those that are new to the channel, I'm going to show you how we do what we call a soft start on an amplifier. And this is something I do on every amplifier that is on this bench. I never apply full mains power to an amplifier straight away. I always do a soft start first. And what is a soft start? Well, it's simply using an incandescent light bulb in series with the live of the mains that's going in. Now, what incandescent bulbs do is the filament inside has its own internal resistance. Now, the trick to them, or what makes them special, is that the more current you pull through that filament, and the hotter it gets, the more that internal resistance increases. And therefore, as the resistance increases, it starts to limit current. The more current you pull, the more it restricts. So you'll hear these things called light bulb limiters or light bulb restrictors. And they're really, really good. The other benefit to them is that because the filament glows, it gives you an indication of how much current the amplifier or whatever the device is under test is trying to draw. And the brighter it glows, the more current is being drawn. If it glows at full brightness, we know there's a short going on. So it's really good. I also have this device here, a watt meter. Tells me the mains voltage of the day, tells me how much amperage is being drawn, and therefore calculates the wattage as well. And I've shown this quite a few times. Now, from experience, what do I expect to happen when I first fire this up? So at the moment, I'm assuming that there is a fault in the amplifier, because that's always the position you need to be thinking from. But let's say it's not. Let's say there isn't a fault. Let's say this thing is healthy and is running fine. Well, when I turn the amplifier on at the wall, I've already got the standby and the on switches in the on position, or the play position, sorry. When I hit this switch, we've got the unit in restriction mode. I immediately expect to see an initial inrush current. So the amplifier is immediately going to try and draw some power from the wall, and we'll be able to see that through the light bulb. It will glow up to a certain level, and then it will die down. Remember, no glow, no current. Then as the valves start to come up and start to warm up and then start to conduct, this bulb will start to glow, and that glowing will increase, and it will settle at a certain point. And if I was to measure the high voltage in the amplifier, we would see the voltage do the opposite to the bulb. So when the bulb is indicating low current, so not glowing, voltage will be high. And then as the bulb starts to glow, the voltage will drop, and eventually they will settle where they are. Usually, with the bulb in place, the watt meter will show around 36 to 40 watts of wall consumption, and we're at 240 volts. Obviously here in the UK. So that's what we're going to do. We're going to fire it up and see what it does. We're definitely in restriction mode. We've got a load connected. In rush current, you see how quickly that went bright, and now it's dimmed down. Pulling 33 watts out of the wall. You see the bulb is off, so there's hardly any current being drawn at the moment. And we'll keep waiting. As the valves come up, you'll see the bulb start to glow again. There you go. So the bulb is preventing the amplifier from pulling all of the current that it wants. Now, what you can do in this state is some really interesting tests. You can, obviously with your voltmeter, you'll be able to find high voltage where you expect to see high voltage. Okay, but crucially, you can also use this to check for voltage where there shouldn't be, okay, and where there might be a fault, because not all faults can be protected from by the light bulb, but at least you can then do that probing, that inspection, see what's going on. So the amp's been on now for 1, maybe 2 minutes, about 35 watts wall consumption today in this mode. The bulb is not glowing bright quickly, indicating that there's something arcing inside the amplifier. It's nice and steady, we're nice and good. I can actually hear a tiny bit of hum coming out through the speakers, so that's good. So now what I'm going to do is I'm going to remove the light bulb from circuit with this switch, and therefore the amplifier will draw full mains voltage and all the current that it wants, and there's no protection other than the fuses in the amplifier itself. Oh, and the fuse in the plug. So I would expect this to go up to, I'd be happy around 90 to 100 watts. Even less would be perfect. Oh, there you go. It's just stabilizing itself. I can see the heaters are on in the valves. I can hear hiss coming through my bench cabinet down here. No smoke, no fire, no indication that there is something strange going on. So now I can switch over to my dummy load. We test the normal channel first. That's the high input. Make sure I set my meter to, my signal generator to 250 millivolts. Tone control is all on 0 apart from the mid. If it's got a mid control, you turn that all the way up. Presence all the way up, and we'll just advance the control, and there's our sine wave. So we are driving 8 ohms today, as is usual. It's a 50 watt amplifier. So to get 50 watts into 8 ohms, we need 20 volts AC RMS output. So let's zoom you in. You can see bottom left hand corner, 14 volts at the moment. And at 20 volts, so that's 50 watts. You can see there's quite a bit of crossover distortion, so you can see at the crossover point between the lower half of the sine wave and the upper half, we've got this lump on both sides. So the amplifier is biased quite cold at the moment. We want those lines to be nice and straight. We're also just at the point of clipping. So if I keep driving the amplifier more, you'll see the top start to square off. So the amp is biased quite cold at the moment, or slightly cold, which means the valves aren't properly or aren't conducting enough of the signal themselves. So maybe is that the cause of the customer complaint? This amplifier doesn't sound quite right because it's biased too cold. Maybe, but I haven't heard this amplifier. So my next job will be to give this thing a good play test and to see what I think. So we haven't done a little bit of a Rift overall update for a while now. So I thought maybe we would talk about how things are going, how things aren't going, you know, the state of the industry, all that kind of stuff. So I have had on the sales side of the business, you know, new builds, taking orders, a pretty terrible summer and autumn so far. Sales have been down quite a bit. I know everyone's skint, I get that. But I've also had quite a few cancellations, which always hits the business really hard because, you know, it's always a fair chunk of money. And I've moaned about this before, but it's part of running a business and I accept it and it's fine. But people don't seem to take that into consideration. And maybe they don't have to. I don't know. It just, it does hurt a lot. The repair side of the business, and I think this is partly down to the YouTube channel, has gone the other way. I know it's repair season at the moment anyway, but I'm getting more and more inquiries for work. I've got a lot more stuff due to come in, which is always good. But the repair side has been, you've kind of got to balance it. The repairs has always been secondary for me to the new builds. You take on repair work when you need it, and you turn it away when you don't, when you're busy. But since the other local guys have all retired and given it up, I'm the only guy in quite a large radius now who does repair, so I'm getting more and more work in. So I did put an advert out for somebody to come and help, an experienced chap. Nobody's interested. All the old boys have retired, they don't want to do it anymore, and I don't have time to train people up, so it's tough. So if you want to help a guy out, and you're thinking about ordering an amplifier, I'd really appreciate it if you do. We've still got that 157 Tweed limited edition 5E3 build available. That still hasn't been snapped up, so I'd be really grateful if someone pulled the trigger on that. Or if you're interested in any of my amplifiers, even if you're not in a rush, I do have quite a large lead time, build time. So, and you're happy to get on the list, please do, because the quicker you order it, the quicker you will get it. So yeah, YouTube channel, it has been growing reasonably well. As you know, back in January or February, the channel became monetized, which means I started getting a cut of the channel, of the ad revenue. And it's not a lot, it's not huge numbers, but it is a nice amount to get. I mean, it gets all invested back into the business and the running costs and things. So it's but it's that, I've always said I was always happy to tell you what I earn from YouTube, since you're the guys that are watching the videos and paying the, who some of you join the channel, so you pay a subscription. At the moment, I earn around £120 to £125 per month from YouTube income, which is, it's not to be sniffed at. It's not great like some of the huge channels get, but for something that I would quite happily do anyway, just to advertise my business, getting that money back to cover the the short amount of time that I actually spend making these videos is pretty helpful. So yeah, it's good. Subscribers, well, we're almost at 4,000 subscribers, and that number increases. So I gain roughly around 200 subscribers per month. So those numbers go up, and that's pretty healthy, I think. People are now watching my videos for longer than they used to. So I don't know what I'm doing differently, but people are saying more engaged with the videos. In the last 28 days, people have watched 4,000 hours worth of my content, which apparently is 317 more hours more than usual. So yeah, it has gone up. And my views, I usually get around 20 to 21,000 views, video views per month. At the moment, in the last 28 days, that's gone over 25,000. So more people are watching the channel, more people are tuning in to see what I'm getting up to. Whether that's because I've had cool stuff in, or because you're just interested in what I'm up to, I'm not quite sure yet. But yeah, it is doing well. As I go through my content, of those new viewers in the last 28 days, 5,000 are new to the channel. Again, so that's great. That's fantastic. People are tuning in. They're enjoying what I'm doing. and it's proof to me that it's actually worth my time doing this, because I'm more visible, my work is more visible, it's bringing in work to the business, and as I said before, this is how I now advertise my business alongside Instagram and Facebook, my social media stuff. YouTube is my primary advertising platform. So there you go. What else can we find on here? My audience breakdown. This is really interesting. So most of you seem to watch my stuff in the evening or in the afternoon and evening. Yeah, I kind of get that. Nobody's watching, you know, after midnight or, you know, the first part of their workday. Fine. Almost 100% of you who watch this are male. I don't know what that says about me or what that says about the content I produce, but I think the last breakdown I saw, it was, let's go to all of 2024, 0.01% of my viewers are female. So yeah, I mean, clearly guitar amplifiers and the inner workings of it doesn't attract that sort of viewer. So yeah, I'm not actively going to go out and try and change that. I'm just going to create content for everyone, as I always have done. And the numbers are the numbers. There's a big difference, I think, between results-led content and content-led results. So I'm quite happy to carry on doing what I'm doing, and the numbers are the numbers. I'm not going to change what I'm doing, chasing the numbers. I think that's where you end up with some quite questionable YouTube content. So there you go. Yeah. So to summarise, sales are down, repairs are up, YouTube's going pretty well. Okay, I gave it a quick play test with the Les Paul, and yeah, it's not quite right. It's got kind of a slightly strange metallic-y feel to it, especially when it's overdriving, where you should have that nice chewy crunch. It's not quite there. So a couple of things I do want to do with it. Obviously, I'll customer's permission. I want to, I mean, the first thing that I noticed is that there are no grid or screen stoppers on the output valves. So the minute the output valves start to overdrive and that screen starts to draw a lot more current, there's nothing helping it and protecting them. It is a pretty common mod on these to add them, like the later models, and I think that's going to be a good thing to do. Also, no grid stoppers, so we'll put some 5K6s in. And if I'm adding resistors to the socket, I'm going to put some 1 ohms in from cathode to ground, so we can properly or easily measure bias in this thing. So that's what I want to do there. And then I'm going to start going through, finding out, measuring values, seeing what's going on. Some people do drop the value of this 330 down to a 250 or a 220. Doesn't make a huge difference, but when you're trying to find those incremental gains, it can. And then we'll take it from there. But yeah, there's nothing, as I said, there's nothing overly concerning about what's in here. But I definitely think we can get this amp back towards what you think these things should sound like. So yeah, that's what we're going to do. Going to add some screen and grid stoppers, cathode bias sensing resistors, sorry, cathode current sensing resistors. It's only Tuesday, I can't talk, and go from there. Phew! Oh, that went on, didn't it? Well, thank you very much for watching. Please give this video a thumbs up. All your comments and questions down below. Subscribe if you haven't already. Hit the notification bell so you know when I put a video out. I am going to start putting 1 or 2 shorter, really quick bonus episodes out every now and again, so you don't want to miss those. Hit the notification bell. If you're feeling really generous, you can join the channel and support me for a small fee, and I will catch you all at the next one.